Hi everyone, and it feels really great to be back as an MC. And our first speaker for the day is Mathias Stoke, and he'll be talking about Bless You, My Deaf. A bit introduction about him. He's a tech evangelist at Always Data, which is a cloud hosting provider, and he's made some security and privacy as one of his challenges. So we'll get to learn a lot from him. And he is a chronic optimist, and his favorite book is Alice in Wonderland. And welcome, and stage is yours.
Okay, thank you. Thank you very much. Hi, folks. I'm really happy to be here today. This is not my first conference with Grass, but my first one in React conference and for the React audience. So I hope this day will be a really good day for you. And my talk is pre-recorded, so we will let it roll, and we'll meet each other together right after for the Q&A session.
Hi folks, I'm really happy to be here for this online edition of React Day. Thanks for being here, and a big thanks to the organizers who kept this edition available despite the current awkward situation. So we're gonna have a quick talk about React. But more specifically, we're gonna talk about its rendering layer and how we can use it to unleash the real power of the framework. Because I'm involved in developer relationships, I'm more concerned with the tool we use every day, the dev tools. But let me tell you that you're concerned too. So you're using React, probably for a while, and you master it enough to build strong application, manage complex UI stacks, plug in it state management system or API connectors, and so on. You develop those interfaces by declaring them using JSX, and you run them in the web browser. So you're a web developer. But you may have to reconsider this, because even if React loves the web now lives a lot outside the browser. Let's see how you can claim much more advanced superpowers. So for a while now, I talk a lot at events about security and performance stuff applied to the front-end environment. And the fact is, we're not simple web developers anymore, because our platform evolved a lot during the last 10 years. So let me remind you of our past through a quick history of web development. 2001, after years of rejections, we start again to consider JavaScript as a serious candidate for animating the web and power interfaces. That's the birth of the first front-end frameworks dedicated to layer animations and manipulation with prototypes, script-tacos, smooth tools, and so on. Then 2005, jQuery arrived to unify developer experience across the available web browser and providing an abstract way to manipulate the DOM and XML HTTP requests. 2010, we decided that manipulating the DOM is not enough. We want to start maintaining state machine in the browser itself and using our backends for data delivery only. That's the birth of Backbone and the new era of single-page applications. 2012, Backbone is nice and brought the MVC pattern in the browser, but it's clearly not enough. We reinvent the concept of development frameworks, but this time applied to the web platform. Angular is the first candidate, and that's a real change of mind. 2015, facing performance issues, the concept of virtual DOM that mimics the layout in the back to make interfaces reactive arose. Its children are React, Vue.js, Svelte, all modern UI frameworks that abstract the rendering to make it simpler to use and to describe. You're not manipulating HTML anymore, and this is no serious game. And nowadays, we're developing PWAs and the web is outside the browser. In less than 10 years, you came from doing HTML and CSS stuff to developing complex pieces of software, still using the same platform, but addressing many more devices. And I say that because one of the biggest changes, one of the greatest pivots, was the arrival of the Pwas era. And it's a big change thanks to just a little thing. Progressive web apps are incredibly powerful. They apply to all websites if you want, but they'd be designed with software development in mind. More specifically, they have all the features we need to build advanced apps. There is an optimized cache to retrieve and store all of our sets, like in distributing an app. There's offline support, making your app ready to run in a networkless environment. Advanced APIs to access the system, notification stack, the hardware, and much more. System permission support, allowing you to store the content in the OS directly. But most of all, they're installable. You can have them installed on your device from laptop to mobile ones without noticing the difference with a native app. And that's the game changer of our lives as developers. Because even if we still use the web platform to power our tools, languages, frameworks, we're not considering running our apps in the browser anymore. You can develop a PWA. You can encapsulate your app in a native-like runner like Electron to power apps that mimic desktop apps like the VS Code editor. You can transpile and bridge your code to build native mobile apps with React Native or Native Script. You can run any Node.js module in a Chromeless browser like Node.js. And you can even target the via field by using the WebVR API. And all of them aren't really browser apps. They live outside the browser. So one of the biggest next changes for JavaScript and the web platform is the IoT field. There's already a lot of frameworks ready to be used with JavaScript to address IoT and so on. There's already microcontrollers and devices that use JavaScript as a main engine. This means that you can develop for embedded devices and IoT ecosystem right now, and that's a really big change. Because we are not web developers anymore. We can do much more advanced things. We can address a lot of fields. Like Java or C developers, you have the power of interacting with any device, anywhere, using one of the most loved and hated languages in the world. This is great power. But great power comes with great responsibility. As our tools become more advanced and more complex in terms of configuration and run, we have to improve their usability. JavaScript is a fantastic tool, but as we saw before, we had to create advanced framework to run it the right way. So brace yourself for the unleashing of the JavaScript power. With the rise of Node.js, we progressively migrated our existing tools like task runners from C or Python to JavaScript 2. One language to rule them all. Much more easy to contribute, to maintain, to release new tools, because the same developers that worked with the final tools were now ready to work on the same tool they use every day. Hitting your own dog food. Sadly, we quickly need much more than just CLI to run them. Because the fact is, we need advanced users' interactions. Look at a simple npm init command. It triggered a set of interactive prompts to help you generate your minimalistic packages and file without any mistake. That's the consequence of crafting advanced tools. They require advanced capabilities in terms of user's experience. So we created a set of tools to help you to improve this developer's experience. Actually, there are smart libraries available to help you with this task. If you need to develop a command line interface with options, flags, and so on, then Commander.js is your favorite tool. It works as a DSL for JavaScript to declare recipes behind commands. If you have to develop an interface with a set of expected inputs to validate and register, then Promptly is a simple high-level dedicated library to this task. If you want a forms-like library for complex inputs and choices, like the npm init command, so the Inquirer.js is the one you want. They are all really great tools, but they're limited to CLI. and they do not offer great flexibility. I mean, if our tools are supposed to power much more evolved tasks, what about having tools that could use advanced UIs dedicated to those advanced tasks? What about using the same tools for time-related visualization or dataset analysis and rendering? And if JavaScript is the next candidate to the IoT challenge, how do we want to consume and configure those embedded devices? What interfaces do we want to craft to our users? I'm working for a cloud provider, the server stuff, hosting challenges, scalability, etc. We have to provide advanced tools to our users, but we're also providers of backend stuff. Among a great web interface to configure and manage your services, we provide an API for automation and a set of tools in CLI for users who need them. It's a screenshot of Go Access, which is an app dedicated to HTTP servers for log analysis and monitoring. It's a simple exact file. It consumes logs and renders advanced information in real time. So this tool is particularly brilliant because you can run it from your terminal, getting a lot of information, like you have here, but in a fancy ASCII interface. But it can also launch a simple web server that renders graphs and advanced metric visualization based on the same log files. So this is two ways to render the information adapted to the various users' use cases. Since its latest major release, the Vue Cli, which is the equivalent of the Create React app for a React project, allow users to interact with a Vue project in the CLI, or it powers a web interface for an advanced user-friendly way to configure your local projects. Those tools, Go Access and Vue Cli, are great because they offer different ways to access the data and interact with it. Sometimes the web UI is not the only solution, nor the best one. In the context of IoT, with limited embedded resources, you probably won't want to waste those resources to run an embedded web server only to give access to the configuration tool. You will more likely rely on advanced CLI tools accessible from a terminal. So that's why we created text-based user interfaces a long time ago. The most common library ready to handle ASCII UIs is Ncurses. There's also a more advanced and more maintained alternative named Ncurses. They're all dedicated to craft complex screens using terminfo declarations and ASCII rendering directly from your user's terminal. They offer a low level of components, the widgets, like boxes, inputs, progress bars, sometimes image viewer or video support, and so on. They're greatly advanced libraries for those who want to design and run complex UI with limited resources. But they're coded in C, and they're exposed as primitives, so they can be easily used from JavaScript code bases. But because our JavaScript community is pretty much creative, we recreated the text-based user interfaces environment in JavaScript. In thousands of lines of code, libraries like Blast or NeoBlast are dedicated to render complex widgets in your terminal, like Ncurses. They offer a large set of low-level components, from boxes to radio buttons or text areas, making the development of terminal-based interfaces way more simple, even from JavaScript. So we can see them like a document object model, but for terminals. And if I say document object model, React is probably not too far. So React is one of the most advanced front-end frameworks, thanks to its reactive design and virtual DOM pattern. What makes it really flexible is the abstractions of the rendering engine. Even if React comes with a web browser in mind by default, the render action can be swapped with another adapter to target another platform. So we do want to craft complex interfaces, regardless of the final type of screen they will be rendered on. Those interfaces will aggregate a lot of components, from boxes to architecture's layout, to form inputs or text areas and progress bar and so on. And all of them will have to display data, take user inputs, and trigger and catch internal events to communicate together. This overall definition is exactly what React stands for. The framework is dedicated to the user interface and delegates the state and the API management to dedicated parts of your application. It has wonderful layout support, allowing you to compose components to build more advanced structures, and it's now robust, well supported, with a strong community, a lot of tools to help you to build a complex application strategy, and it's not limiting you just to the interface. So, despite the fact we want to target terminals and text-based user interfaces here, maybe we can stick to our well-known technology rather than using new libraries. Maybe we can take strong advantage of the existing ecosystem to craft a reactive interface using ASCII character rendering libraries. Because if React is a great layout engine, its rendering abstraction is the key to the greatest use cases. So, of course, we have a binder for the blessed library that exposes a React render layer ready to handle your interfaces in the React way to populate your terminal screens. And any of the blessed widget can be rendered through the React blessed, from the text nodes to advanced elements. From the React side, it supports class names and CSS-like styles and style sheets. And from the blessed side, properties and actions are accessible from the JSX syntax with a nice syntactic sugar. So, from my React components, we still stick to the same logic. There is nothing really new on this side. We import React and the component low-level class. The render action comes this time from the React blessed layer. It will handle the rendering process to ASCII screens rather than for the web DOM. And we also need to import blessed itself, the library, to create the default screen from the default widget. It declares the rendering context. We may consider it as a default viewport element, like the body element in a classic DOM tree. So I attach my application to my blessed screen, and that's all. So we can manage our layouts. To do so, we use a blessed box widget, which can be considered as a div element in a DOM tree. Here we declare an add component which simply renders a box. This box covers a quarter of our total screen, 50% width and 50% height, and we center it on the screen. Easy. We also declare a line border using the border property exposed by the blessed widget, and we simply populate it with a simple text node, which takes the form of string injected in the parent component, and that's all. So this app is rendered into the screen we declared at the last step. So here we go. We've got a message box in our terminal, centered in the middle. But we do need more advanced interfaces. So here, we want to craft a progress component that displays a simple label above a progress bar. So we first extract the progress value from the component internal state or from the application state, and then we generate the related label. In a top box that exploits a given attribute for its rendering appearance like size, position, and so on, like we saw before, we first put in place another box to handle our label. Because there is no text widget exposed by the React blessed library, so we do have to use the blessed box widget. Like we do with divs when we work in a DOM-like environment. And we inject the string of text. We do so by using the generated label directly in this box. Then we open the progress bar widget filled with the regarding value extracted from the internal state and with the color stored in this state too. To do so, we use the blessed widget style property that expects dictionaries of value. And here there is a background color in a bar dictionary. But React Blessed also supports a wide range of actions and of events applied to each types of widgets. So here we can attach key events using a handy binder with the key function. We first attach to the global context, the screen, with the key event on escape, Q, or Control C when the key pressed. And it triggers a callback function passed to the key declaration. Here we simply execute the main process, resulting in closing the application. This key handler can be attached to any kind of widget. But the blessed widget also supports internal actions or events. So React Blessed exposes them using the React convention by prefixing events curlies with the on keyword. So here, on the previous progress bar components, we attach a callback on the onComplete event that calls the internal state action and update the bar background color property, so that trigger the render of the component to update the progress bar color in a React way. So thanks to this architecture, we can exploit the forms and the prompts widget in Blessed to compose complex views. Here, there's a component that exposes two internal widgets. The first one is a list of elements. It takes 90% of the container height and displays all items stored in the internal state. They can be, let's say, messages from a chat room, for example, and they've been recovered for a previous API call when the application launched. Then the second one is a text area widget, which allows you to multi-line input. So it takes the rest of the screen height, and it will be used by the user to input some message and store them in the state item list. To do so, we will rely on the reference strategy to keep a pointer onto the widget. So then we can use this reference to register events like submit and trigger a callback action that saves the input and clears the text area content. We can also use this ref to register key events thanks to the blessed internals to submit the content when the user presses the enter key, still using the references. So Blessed is a very compliant library that exposes a lot of widgets, boxes, lists, forms, prompts, table, logs, and so on. You can easily compose them for more complex views, and every Blessed widget is available through React Blessed, making them really easy to declare and to extend into your React app. Unfortunately, Bless is not well maintained for a while, so forks appeared like NeoBless, and by default, React Bless uses the original Bless engine in the back, but you can easily swap it with NeoBless or Bless contribs. There are two forks, by importing the module and calling the create Blessed renderer function from the React Bless module with the React Blessed instance rather than directly importing the default React Blessed render function. And it works, so you can easily tweak it and easily use it in every kind of context using the last maintained library and community libraries. So here's your superpower, I said. And this was my point at the beginning of this talk. React is an awesome framework and one of the best solutions available today to develop complex interfaces. Its smartest point is the rendering abstraction. Using the JSX syntax and some custom rendering engines, you're able to address a lot of devices and platforms, not only the web browser. And because you're the first users of our tools, our dev tools, you can improve and unleash developer experience by crafting awesome interfaces, whatever their environment is, both for the web and for the terminal interfaces if you want. Because React is available everywhere on multiple platforms. You already heard of React Native that compiles to native apps for mobile devices, but you can also write desktop interfaces in pure React by using React Node Guy. Its purposes are the same as React Native, but for desktops environments. You can generate complex PDF files using React PDF. You can even craft complex 3D VR scenes with React Frame. So there is as many possibilities as there are rendering engines. You just have to pick the right one to do what you want. So you know the web, but you're not web developers anymore. You're way more than just developer for the web environment. Using your existing skills, you can access a lot of platform. You've empowered developers and probably one of the most advanced in terms of delivering great users interfaces. So thanks, I'm Mads. I'm a tech evangelist at Always Data. We're a cloud provider, as I said before. We work on dev tools for our users, and we want to be able to provide advanced interfaces, even in the terminal. So for us, it's a guarantee of great developer experience, and we're working a lot of those topics. That's why we are targeting some interfaces like with React Blast. If you've got any question, we now go live for a Q&A session. And for everything else, I thank you very much for this your attention and for being here for this new talk in the React Day online edition. Thank you very much.
Hi, that was a wonderful talk.
Thank you very much.
And I have questions for you. So the first question is, why focusing on terminal instead of creating web UI?
Well, that's interesting. In fact, the Blast project started just a pet project just to test something, just to try to see if we can render some kind of terminal users-based, text-based interfaces using JavaScript. And in fact, it works, and it works really well. So as a developer, I'm more comfortable sometimes in my terminal rather than using some dedicated tools or web UIs. But and this is the interesting fact. React gave us a choice to develop different types of interfaces. We can choose to develop for the terminal or for the web or for other kind of interfaces. And this is what it's really interesting for me right now. This is just, we don't have to just focus the web browser anymore. We can focus terminals if you want, or if you need to do it. And we can stick to the existing well-known technologies that we already mastered. So yeah, crafting interfaces for the terminal is sometimes a toy, but it's really interesting and really fun to do. So why not using it?
Thank you for the answer. I have a next question as well. Could we imagine another way to render the interfaces?
Yeah. Yeah, this is a good question. We can already focus other kind of interfaces, like PDFs or WebVR or something like that. But we could imagine in the next future other devices, other environments that we can address with React too. 6 years ago, there was a really good talk called The Birth and Death of JavaScript. And this talk is a good exercise of reflection from the beginning, the birth of JavaScript in 1993, to 2030, something like that. So this is 35 years of reflection about how we can improve JavaScript and how we can use it in our everyday, and probably we are more and more moving from just the web environment to something more deep level, something probably at kernel level, using technologies with WebAssembly or so on. So right now we're just targeting some kind of environments, but in the next future, yes, I'm pretty confident that we can continue to address other more complex interfaces, still using React thanks to the abstraction of the rendering layer.
Got it. Yeah. There's one more question for you. Are there any performance issues developing with React in a non-web environment?
It could, because the performance issues are mainly in the rendering layer. So the React core is responsible of computing the virtual DOM, and there is a lot of effort put on the improving of the performances of the virtual DOM, especially with a new module developed with WebAssembly to improve the performance and fasterize it. But if the rendering layer is slow for some reason, the rendering could be slow. With Bless, this is not the case, because addressing the terminal is some kind of pretty easy, because this is just rendering text and ASCII characters. So it's pretty quick. But yeah, we can face some kind of rendering performances, but they're located in the rendering layer, so we can still find some way to improve them.
Thank you. Thank you so much again. It was a
Thank you.
wonderful talk with a lot of insights. So thank you very much.